Hello, you're welcome to our channel once again. Today we shall be calculating the energy generated from hydrodynamic structure. Now, let's read through our question. Calculate the energy generated from the hydroelectricity energy generating plant in the schematic below when its dam is height of 30 meter and the overall head loss equals 60 meter and the flow rate equals 2 meter cube per second. Assume the turbine efficiency equals 0.75. Once again, calculate the energy generated from the hydroelectricity plant drawn below when the height of the dam is 30 meter and the overall head loss equals 6 meter and the flow rate equals 2 meter cube per second. Assume the turbine efficiency equals 0.75. Now, by using the schematic diagram representation below, we have the height of the dam, which is 30 meter given. We have the atmospheric pressure of the water on the left and the atmospheric pressure on the water surface on the right hand side. Now we know that the atmospheric pressure here is steady and on the right hand side is also steady. So therefore, let's pull out our parameter. We have the height of the dam, which is 30 meter. We have the head loss given 6 meter. We have the flow rate 2 meter cube per second. We have the turbine efficiency 0.75. We have the density of the fluid flowing through the dam 1000 kilogram per meter cube, and we have our G, acceleration due to gravity, 9.81 meter per square. Now, how do we calculate the energy generated in kilowatt? We are asked to calculate the energy generated in kilowatt using the parameters given pull out from our question. By using the energy balance equation, which is pertaining to the heads of the fluid passing through the hydro dam, we have our V1 over 2G plus H1 plus P1 rho GAG minus V4 over 2G minus H4 minus P4 over rho G minus HL. HL is a head loss, and the plus HS. HS is the shaft loss, head of the shaft, which is equal to 0. Now, by using the dam representation, the velocity on the dam, being that the water is steady and is calm, so the velocity will be 0. So V1 and V4 equals 0. Also, their pressure will also be 0 because it is atmospheric. Both pressure on both sides are atmospheric pressure. Now, our energy balance equation becomes H1 minus H4 minus HL plus HS equals 0. So therefore, our H1 minus H4 equals H. Now, because there's no shaft work, so the shaft work will be 0. So therefore, our shaft work will be 0. Now, our H minus HL plus HS equals 0. And don't let us forget that the HS equals H pump minus H turbine. Since there's no pump in our dam, our H pump is cancelled, equals 0. So our HS, which is shaft head, equals minus negative turbine. So therefore, when we put our HS into the equation here, then it becomes H minus HL minus H turbine equals 0. So therefore, our H turbine equals H minus HL. Our H, which is the height of the dam, equals 30 meter minus the head loss, which is given 6. That gives us 24 meter. Now, using the formula of the turbine work done on the turbine, which is equals mass flow rate times density times G, acceleration due to gravity, multiplied by head loss of turbine over efficiency of the turbine. So that gives us our rho, which is 2, our density, which is 1000, our acceleration due to gravity, which is 9.81, our H turbine, which gives us 24 meter, over the efficiency of the turbine, 0.75. That gives us our work done through the turbine, which is the energy generated. So therefore, we have 628 kilowatt generated from the hydroelectricity dam. Thank you.